Well, I hope you find this interesting. What if we had a function of three variables, like f of x, y equals x squared over 4 plus y squared over 4 plus z squared over 4, and our interests were like, well, I can't graph this thing because it would take 4 dimensions to do that. I've got a 3-dimensional domain, so I can't see the graph. Well, we couldn't see this graph. If we could imagine we couldn't see a 3-dimensional graph, but we could see the contour lines, that would give me a pretty good picture of the behavior of the function. And so we can use the similar idea to finding level curves. Instead of level curves, level surfaces. I'll give you an example for this one. If w was equal to 0, then we'd have the level surface 0 equals x squared over 4 plus y squared over 4 plus z squared over 4. So in other words, w equal to 0 forces x, y, and z also to be 0, so it would be just the point, the origin. But if w is equal to 1, then we'd have 1 equals x squared over 4 plus y squared over 4 plus z squared over 4, so x squared plus y squared plus z squared equals 4. We would have a sphere of radius 2. And if w is equal to 4, trust me, we would wind up with a sphere of radius 4. And if w is equal to, let's say, 5, we'd have a sphere of radius 20. But we don't know the function. We can't see the function. We don't know what we've got, but we know what the level surfaces are. We can do that.
My mom always said life was like a box of chocolates. You never know what you're going to get.
Well, that's true. We don't know what we're going to get, but we do know what the level surfaces look like. Okay. Now, with a computer, I struggle sometimes making these graphs visual for you. Here's the graph of the function x squared plus y squared quantity times e to the 1 minus x squared minus y squared. That's tricky, but you know, I can modify it a little bit. Suppose I wanted to put a 2 in front of that. Well, here, as you can see, it's starting to split apart. That's certainly interesting looking. What if I put a bigger number in front of that, like a 6? Then what happens? Then you can see I clearly have 2 holes in this thing. Wow, this is a fantastic looking graph. What if I decided to do something different with the x and the y? Suppose I put a 2 in front of the x squared. Then what happens? Well, then I get 2 peaks to the thing. All right, let's do that in a 2 in front of the y. Let's see how interesting that is. Wow. So, you know, you can use computers to graph some strange animal functions. Let's see what happens if I put a 2 in front of the y. What does this look like? Well, that kind of shrunk it down a little bit. So I'm not sure that was helpful, but I think you get the idea. Here's another one that's kind of interesting. It's f of x equals negative 4x over x squared plus y squared plus 1. Notice, since there's no issues with the denominator equal to 0, the domain of this is all real numbers. But I want you to notice something. If x was equal to negative 1 and y was equal to 0, we'd have negative 4 times negative 1, which is 4 over 1 plus 1. So 4 over 2, we would get a value of 2. Well, look at this. When x is negative 1, that's about here, and y is 0, we have a peak value for this function. Actually, it would be called a maximum value for this function at the point 0, negative 1. Actually, yeah, x is 0, y is negative 1. We have a maximum value of 2. And if x was equal to 1, this would be negative 4. And again, let y be 0 and x equal to 1, we'd have negative 4 over 2. So our function goes down to z equals negative 2. We have a minimum at that point. So I bet you're intrigued already, thinking that, are we going to be finding maximums and minimums for these, shall we call them, surfaces? And the answer is, yes, we are.